as I was saying you that almost every company is looking forward to implement the solution of SD-WAN in the production environment. So when we look at those solutions, it's kind of something that would actually help you to manage multi-site deployment, right? The name itself says SD-WAN because it's like the full form kind of specifies that it's software defined wide area network. So it's not something that your WAN network is completely being redefined in order to like a lot of people are also thinking that it's complete you can say replacement of MPLS or replacement of something that is already deployed as a part of the transport, but that's not something like that. So when we talk about it, then you can say that it's a way to access your WAN networks in a better way possible. However, we'll get to know about it. But basically talking about you can say the course itself. I'll give you a glimpse about the course. Then I'll give you a glimpse about what all are the content that we're going to cover. I'll give you the glimpse about what all are going to be the labs, and then we'll move on with how we are like looking forward to cover the content and all. So let's go ahead. Just give me a minute while I share my screen with you. All right, that's great. So we're going to start the session by having an introduction to everyone that we have on board in this particular training, and then we will move on to dig deeper and to learn about what is SD-WAN, what's the underlying technology that we use, which is software-defined networking there, and then we'll see how the controller setup is done and how the deployment setup is done. One by one, we'll get to know about everything that's actually there. So, talking about myself, I'll give you your instructor information first. So, as I told you, my name is Abhijit, and I belong to a state of Maharashtra in India, but I live in Delhi now, Gurgaon to be very specific. Those who are from India would make sense of it. So, yeah. And if I talk about my technical skills, then I've been delivering corporate training since last 8 years. And my key interest earlier or at the beginning of my career was routing and switching. Then I learned some technologies of security, some technologies of data center, and some technologies of service provider networks. And then I completely switched my key interest into kind of deploying network automation and stuff like that. So as Cisco came up with the recent certification changes, I kind of moved on and grasped whatever knowledge that I need to grasp in order to make most of how network automation actually works. So since that time, I've been delivering corporate trainings, or my last couple of years have been pretty busy in delivering corporate trainings on technologies like SD-WAN, on technologies like network automation, on technologies like how you can use Python in order to implement network automation and other things, right? We also have some of the candidates who have attended my previous trainings as well, like Rick is there, right? Yeah. So we at PyNet Labs are looking like we at PyNet Labs are having our USP as network automation and solution deployment, things like DNA and SD access and SD-WAN and network automation. That's what our USP is in delivering professional trainings or corporate trainings all around the world. So yeah, and if I talk about the objectives that we can have, in order to complete this particular training, I would say that um, we have an objective to understand the solution itself, understand the technology itself. Okay, and then we are going to have your hands-on lab built on specifically from scratch. That you guys won't be having any topology. You guys will just be having a picture of the topology, but you guys will be designing that topology by yourself, and then I'll help you demonstrating that how you can build up your SD-WAN deployment and how you can like do the onboarding process of all the like multi-site deployment that you have, that you may have in your production environment. So yeah, that would be my introduction. If you guys have any questions, you can please go ahead and ask your questions. Otherwise, I request one by one, each one of you to please introduce yourself and tell me about your name, about your company, what do you do, what are your skills and like knowledge that you have, and what's the objective of joining this particular training that we are over here for. So we have Rick with us. Rick, please go ahead and introduce yourself to everyone.
Good morning, AB. Good morning, everyone. My name is Rick Wood. I'm a freelancer working in the Netherlands. I've been living and working in the Netherlands for almost 20 years as a senior IT engineer. So I've got a lot of experience working for the Vodafones and the Ericssons of this world. I've actually taken SD-WAN training before and passed Cisco certification exam, but I want to retain my knowledge and skills for any future jobs that come along. So I'm keen to learn some new information from AB and maintain my skills for SD-WAN. Okay, thank you.
That's good. Perfect. Thank you, Rick. Then next we have Debashish. Debashish, please introduce yourself.
Hi, I am Devashish Reddy, actually currently working in Wipro as a network architect. And basically, I have 18 years of total experience on that. And basically, my skills are on routing and switching Wi-Fi. And that is why I'm learning for this, because this is the new technology need to be added and very required one. So I'm here to be on this training to get a good knowledge. Thank you.
Perfect. Thank you so much, Debashish. Then we have Lokesh with us. Lokesh, please introduce yourself.
Hi everyone, this is Lokesh here. I'm from India, Bangalore. I have 9 years of experience and from past 2 years working in SD-WAN. I have very limited exposure on Versa SD-WAN technologies, and I have been working for 2 years for Cisco SD-WAN solution, and currently I'm working in Wipro Limited. Where only we have access to these core devices, I mean the edge devices, not to the hub, and we don't have exposure on Vsmart, vBond, and Vmanage.
Okay.
So the purpose of this training is I wanted to learn everything in and out of the SD-WAN technology, how everything works. We build the entire infrastructure.
That's great. That's great.
And I have exposure only on Viptelas, so I'm more curious to learn Cedge, triple O series and 4000 series.
Okay, perfect.
That's all about myself. Thank you.
Sure. Thank you so much, Lokesh. Then we have Romel with us. Romel, please introduce yourself.
Hi, good morning, everyone. My name is Romel Walhati, currently connected at PXC Technology, so located in the Philippines. My current role is a solution architect, including the engineering and implementations lead. I have more than 10 years working in routing and switching and security as well, with different deployment, campus, data centers, and telecoms. So my objective is basically since we're planning to migrate it to SD-WAN. So my expectation is understand with that technology particularly.
That's great. Thank you, Romel. Then we have Philip with us. Philip, please introduce yourself to others as well and to me as well.
Hi, good morning, but in my case, it's good morning to you all. It's good night to you all in my country. I'm from Barbados. And it's now it's about 10, almost 11 o'clock in Barbados at this point in time. But nevertheless, I'm an IT consultant. I have worked as I have about 10 years, probably 10, 20 years in IT. Last 10 years I was as an IT manager for a company. And recently I just started a new company as a consultant providing IT support services. Have a suite of certifications, as well. Last certification I now complete with the CCNA. What I would say, I'm really interested in SD-WAN. I want to get more involved with this technology. I heard that, well, not heard, but I more understand that that is the way how configuring of the network is now going, being able to manipulate different hardware and be able to configure it. What else could I say? This in a nutshell, I really want to get a better understanding. That's all.
That's
Of this
fine.
technology.
It's really great that you're dedicating your time where you need to go to sleep
Yeah.
as well.
Yeah,
You're
that's
spending
true.
your time learning about the technology. That's great to have you on board. Thanks for
All right, thank
introducing
you very
yourself.
much. Okay.
Yep. Then we have Roshan with us. Roshan, please introduce yourself.
Hello everyone, good morning. I am Roshan,
Mhm.
currently my base location in the Bangalore, India. I am currently working for AT&T as an engineer. And last 1 year I have worked on 128 technology, that the SD-WAN technology for the US. And
Uh-huh.
I'm completely new in the SD-WAN, and my base role skills, you can say, routing and switching. And I joined this course because I want to learn too much on the SD-WAN as 128 technology, which in the US currently I don't have too much exposure because we don't have too much access, you can say. And mostly access with the US guys, and Indian guys don't have that much access. And the best
Okay.
thing for joining this course to learn much more on the SD-WAN. Thank you.
Perfect. Thank you so much, Roshan, for introducing yourself. And yeah, I wish you all the best for this particular training, and looking forward to like have the most out of this particular training. So yeah, thank you so much everyone for introducing yourself, and we'll move on now with the content that we actually have to cover. So
Maybe I have
when
one
you
question.
go ahead.
Do you provide any study materials, or we have to make a note as on you go on with the training?
Well, I will be providing you the study material, like the official books and all. Okay, but the thing, like the PPTs and all, will be shared with you as well, and the recordings will be shared with you as well. But while we do the hands-on lab, then I'll recommend you to note down the steps that we are actually doing, because it's gonna be something like I'll be doing the lab and I'll be explaining you each and everything, and then I'll be providing you enough time to do the lab in like real time itself. So while we are in the class, once I'm done with my lab, then I'll be telling you guys to do the lab, and then if you face an issue, then we'll troubleshoot that particular thing.
Oh,
So while we do the lab, I'll suggest you to please make your notes real
oh,
time.
yeah. Thank you.
Right. Apart from that, the recordings are going to be shared with you. So whatever I write on the slides, or whatever I use as annotation on my screen, it's going to be shared with you. Okay.
Oh, thank
So
you.
yeah, that's something that's covered up. All right. So if we talk about something, you can say that. Just a minute. Let me share my other screen as well with you there. So as we all are here, and now if you can please confirm if my voice and like everything is clear, my screen, there's no lag in the voice and video from my side, so that will kind of be great to, we can say, confirm that there is no issue in my internet. Perfect. Thank you. So when we look at it, I would say that the course is of course going to be for SD-WAN, right? So first thing first, we actually need, because SD-WAN is kind of a children technology, and the parent technology that's there is SDN. So you can say SDN is something that we need to do, like that we need to get a small intro to. You probably might know about SDN introduction, because there are some candidates who have attended my previous batches as well. But that's fine. We're gonna give it a brush up for them as well. So SDN has divided a couple of things as SD access, and then you have SD-WAN. These are the two children technology that comes under SDN. Okay, so software defined networking has software defined access as one part, and software defined WAN as the other part. When we look at SD access, it's completely to manage your LAN infrastructure. okay, in a centralized environment. And if you look at SD-WAN, it's completely built up. It's a solution that has been built up in order to manage your WAN environment from a centralized point of touch. Okay, and the solutions that Cisco offers, because the course that we're going to take specifically is made for Cisco's SD-WAN solution. I would say for SDX's, the solution that they have came up with is DNA. Earlier it was Epic EM, but then it has been renamed to DNA. Okay, and then if we took a look at the SD-WAN solution that Cisco has Viptela SD-WAN solution that they implement. So DNA is basically a tool or a GUI solution that we actually use in order to manage the entire LAN infrastructure. And Viptela's SD-WAN solution is something that we actually use in order to manage all the WAN infrastructure. Makes sense? Now, when we talk about the same, you can say that the course is going to be dedicated to cover this part of the SDA journey. Okay, but first thing first, we're gonna of course start with intro to SDN. What is actually SDN? And then after that, we'll be like moving on and getting to know about various other things that are basically there. Or you can say that we'll be learning about the technology itself. We'll be learning about what all are the sections. So after getting to know about the intro to SDN, we'll take an introduction to SD-WAN. Like, what is this SD-WAN? Okay, and then we will talk about SD-WAN components, where you will get to know about what's you can say Vmanage, okay, what's vBond, what's you can say Vsmart, and what's Vedge. Apart from that, you will also get what's Cedge. These are different you can say controllers that you're gonna get to know about, okay, in the third section of our training. Then after that, we'll be moving on and we'll look at how control plane and data plane operations are done in SD-WAN. Okay, so you can say, yeah, how control plane and data plane operations are done. That's what we'll be looking at. Then after that, we will learn about how onboarding procedure is done. Okay, or you can say onboarding and provisioning of the controllers. How we can actually do that. This will kind of be completely a lab oriented scenario. Okay, and then we will get to know about uh, different policies. You can say SD-WAN policies. After policies, we're gonna get to know. So it's all about policies, and then we'll also cover a short part about SD-WAN security. Okay, so in policies, it's going to be local policies, centralized policies, application aware routing policies, or various other policies that are going to be covered there. Okay, and then we will get a glimpse about security, and then after that, we'll get about or a glimpse about how migration is also done, because a lot of companies will actually need to switch from the traditional network to SD-WAN network. So how does that migration thing works? That's what we're gonna give a glimpse on, and majorly these are going to be our core key topics that we are going to cover. Okay, the training is going to span from you can say it's starting from 1st of March, of course, and it's gonna end up on I think 19th of March, right? So it's gonna be around like a 4-week training, and the training is being conducted from you can say 8 a.m. IST to 11 a.m. IST. These are our timings for this training, okay, daily. And yeah, that would how the training is actually dispersed. The lab access will be provided to you guys when you need them. Oh yeah, that's a 3 week training. Yeah, not 4 weeks. Sorry about that. So the lab time, the lab access will be provided to you probably on second or third day that we're gonna need them, and you will have the lab access with you around for 4 to 6 hours, depending on what kind of lab that you will be doing over there. So yeah. Now, when we would actually discuss about the concepts over here, then you can say that it's fine that you can take your notes as well. But while we do the labs, then I'll be demonstrating you that what the lab needs to be done and how it needs to be done. And I'll request you to please not follow me while I'm doing the lab, because then it'll kind of create confusion for you when I'll like ask you to do the lab as well. Okay, so it's better to first see the demonstration, understand how the lab is actually done, make notes of that, and then I'll be providing you enough time in order to do your own lab as well. So that's how we're gonna keep the thing up. And yeah, that was the introductory part. I would say that we actually needed to look at, and then let's get started. So, as you probably might know, that Cisco has came up with all the certification changes, right? That Cisco came up with, and the training that we are like having is part of the certification as well. So there is like CCNA certification, there is CCNP certification, and there is CCIE certification. That's there, right? If you talk about CCNA, CCNP, and CCIE, earlier each of this particular level of certification, be it associate, be it professional, or be it expert level certification, it was all binded with a specific track. So you were having tracks like routing and switching, you were having tracks like security, and various other things, right? But CCNA has completely been off track, and it is no longer associated with any track. So it's no longer a part of routing and switching or security or any other thing that's there. Okay, when we look at that particular thing, the track thing actually starts at CCNP. So routing and switching, which was earlier there, it has now been renamed to enterprise. So you no longer have any certification that is called as routing and switching. Whatever you have now is enterprise, which is the replacement of routing and switching. So you have CCNP routing and switching, you have CCNP security, you have CCNP data center, you have CCNP wireless, and various other tracks that are there. Also, cloud was one of the tracks that Cisco was offering, but it has completely been removed. So it's no longer available. And if we talk about these certifications, how they're done, then earlier there were like specific modules that you actually needed to pass in order to become a professional. Like if you wanted to become CCNP routing and switching, which is now equivalent to CCNP enterprise, then there were three modules, right? You had CCNP route, you had CCNP switch, you had CCNP t-shirt. So when you look at these three modules, then you needed to pass each exam. And if you pass all of these exams, then and then only you will be called as CCNP routing and switching. That was exactly how the thing was, like before Cisco coming up with the newer certifications. But in 2020, Cisco came out with newer certifications, and the module completely changed. So now how it works in order to become CCNP Enterprise Certification or CCNP Enterprise Certified uh, is there are specific certifications or modules, and they are divided into two categories. So the first category that you have is the core exam, okay, and the second category that you have is the concentrated exam. The core exam and the concentrated exam. So every module that you or every track that you have has a core exam, which is basically a mandatory exam. In order to become CCNP or Cisco Certified Network Professional in any track, you actually need to pass the core exam. So for enterprise, it's actually ENCOR, which is NCORE. Okay, and NCORE is basically an exam that you actually need to pass. Then in concentration exam, there are multiple types of exam that you have here. You have one as NRC, which is for advanced routing and services. right? Then you have the second one, that is SD-WAN exam, or ENSDWAN or something like that. Then you have ENWLSI, wireless implementation. Then you have something like an auto, and then there is something else as well, which is I guess design. So these are kind of the exams that you have. Now, if you pass your NCORE exam and then you pass your NRC exam, you will become CCNP enterprise, which means that you need to pass a core exam from your concentrated, from your specific domain or stream, and then you need to pass one of the concentrated exam, any one of the concentrated exam. You can pass SD-WAN, you can pass wireless, you can pass NRC, you can pass, yeah, there is also another thing called, yeah, the an auto, which is basically the automation one. So yeah, you can pass any of the concentrated exam and combine it with the core exam that you have, and then you will become CCNP certified. So the training that we're going to have specifically focuses on the SD-WAN concentrated module that you have here. Okay, so if you already have a NCORE certification, then you can go ahead with this exam, which is of SD-WAN after this particular training, and it would be there to help you there. Just a minute, guys. Yeah. So as I was saying, that you guys can actually do any of the like combination of the exams, but a core exam is a needed one in order to become a professional. And if you do not like pass these exams, let's say that you go for just NCORE exam, or you go for just the SD-WAN exam and doesn't really have the NCORE certification, then there is a new like badge that Cisco have started giving, which is called as Cisco Certified Specialist. This is basically a tag that you will be receiving if you just pass any individual's like module and not the combination. For example, if you just pass in core, you will be called as Cisco Certified Specialist in Enterprise Core Technologies. Okay, if you just pass SD-WAN, you'll be called as Cisco Certified Specialist in SD-WAN. And if you even pass all of these, okay, all of these specialized module, but you don't go for the encode, then you will be getting all these specialist tags for all the technologies that's here, but you still won't become CCNP until unless you pass the core exam. So that's what the requirement is as of now for all the professional exams. And earlier in CCIE as well, you used to have your CCIE written exam and then your CCIE lab exam. So you needed to pass your written exam as well. There was a different exam for CCIE before, but now the core NCORE exam or the core exam for every track just acts as the CCIE written exam as well. Okay, so that's something that you need. That's kind of a beneficial for you. Okay, and then now you can, if you have the core exam passed by you, you can directly go for the CCIE lab exam as well. So that's kind of a glimpse on the new line of certification that Cisco have came up with, and that's exactly how it works. I hope that sense is good to you all. If you have any question, you can please go ahead and ask that. Otherwise, we can move on to the next topic that we need to discuss. So after, as we had the glimpse about what all are the you can say concepts that we're going to cover, and what are all the course curriculum for this particular training, the first section is actually completely based on introduction to SDN, or how does this software defined networking thing actually works. Okay, so if you look at that, I'll give you a glimpse about what SDN is actually and how SDN works. So let me just get clear with that. So in order to understand how SD-WAN actually works, it's a must have requirement that you should be able to you can say make the difference between what is like and how you can say traditional network has been behaving, and what are the different ways that are available in order to manage your traditional network. And by traditional network, I mean that how currently are we managing our large network scenario or even small network scenario? How does that actually work? So in order to identify that, you actually need to understand what is SD-WAN and what how does the traditional networking actually is working, and what are the like cons of those technologies that we're using. It also has pros as well. I'm not saying that there is no pro in that, but yeah, there, like if you look at the perspective of the complex network, then there are a lot of cons that we have nowadays because the network is becoming much complex now. So the first section of the day is going to be introduction to SDN, software defined networking. Right now, I usually give this particular introduction in most of the training because this is kind of a prerequisite that we actually have. So what is SDN and why is it becoming popular? And one of the biggest misconception that everyone's having nowadays, or almost everyone is having on nowadays, is whenever these automated tools or these auto configuration tools or centralized policing tools are being deployed into the production environment, it's going to eat up the jobs of normal people, because most of the people or most of the network engineers are pretty, it's pretty common that they would be doing the like daily repetitive tasks into the production environment, like creating VLANs, creating interface configurations, routing configurations, and these are kind of assumed as the like normal jobs that they do, or that most of the network engineers do. And people are having misconception that when automation or when this automated tooling is going to be installed into the production environment, it's going to eat up the jobs of normal people that does the repetitive task every day. Because what is being thought of is the solutions are quite good in doing the repetitive task again and again and again. Well, I would say that, as I said, this is kind of the biggest misconception and not the correct conception that people should have, because it doesn't really matter that the man force is not going to be affected that will be needed in order to manage the network, because the network is not gonna stop becoming critical or becoming complex as we move on with like every year the network is becoming complex and complex and complex, because technology is kind of like growing in a rapid way possible with the help of applications like Internet of Things, with the help of applications like machine learning and artificial intelligence and virtual reality and whatnot. There are so many technologies that almost every device actually needs to be connected to the internet now, right? We have our, earlier in the last decade, we used to have our phones and our computers connected to the internet. But nowadays, it's like even our refrigerator, even our TV, even our like the complete home automation thing is kind of going to be so revolutionary that almost every device is going to be connected to the internet. And there are going to be thousands and thousands of applications that would be hosted into numerous data center all around the world in order to serve to those like home appliances or serve to everything that we actually use in our daily lives. Now, in order to keep the network up, the network, of course, is going to be pretty complex. So man force is not going to be something that's going to be reduced, because man force needs to focus more on how networks can actually be optimized instead of focusing on how repetitive tasks can actually be done in a better way possible. Right? Do you understand what I'm saying? So it's not actually something that you need to like. You should not really do the job of creating repetitive configurations, or doing repetitive tasks every day into the production environment. You should actually focus on how your network can actually be optimized in a better way possible. Make sense what I'm talking about? So that's kind of a biggest misconception that people have. And is this particular misconception real? In order to understand it technically, you need to have your like understanding towards SDN. What is SDN and why is it actually works? Now, in order to better understand that, you actually need to understand how traditional networking actually works. So when we look at traditional networks, now what is this traditional network? So you can say that networking I would say always has been traditional, or very traditional. You can say for the past 20 or 30 years that we have been using it, right? And we have various like specific devices that we actually use. Like we have router, we have switches, we have firewall, right? We have IDS, we have IPS, we have load balancers, and we have various other devices that are there that can actually be deployed into the production environment. Make sense? So when we talk about these things, I would say that these devices are actually created by different vendors, right? We have vendors like Cisco, we have vendors like Sienna, we have vendors like Juniper, we have vendors like Huawei, we have vendors like Nokia, and there are various other vendors that actually creates all these devices. Okay, F5 and FortiGate and Checkpoint and Palo Alto. Okay, there are various other vendors that actually creates these applications, or sorry, creates these devices that we deploy into the networking scenario. So if you have any device, how do you actually access it? So you have a router there, and that particular router can actually be connected with the management PC, right? So this can let's say be your management PC, and you are connecting it by using a console cable, okay? And you're attaching that particular RJ45 plug into the con 0, right, or console 0. And then you, in this management PC, you'll be opening up an application called putty mostly, and then you will be accessing the CLI of that particular device by using the putty as the software. So putty gives you kind of a CLI access, and then you enter your all the configurational commands, and that's exactly how you configure the device, right? It's also possible that you are connected with that particular router over the ISP or over the internet, and then you are situated somewhere down over here, and then you are using management PC, and then you are establishing an SSH connection or a telnet connection with that particular device and remotely managing that device. That's also possible, right? So there are various ways in order to implement device configuration. Now, if you replace these devices with the latest devices, let's say something like ASA, right? So if instead of having that router, if you have an ASA, that ASA can actually be managed from the same management PC, right? By connecting with M0 interface or management 0 interface. But instead of using putty CLI, you can actually use ASDM, which is Application Security Device Manager, and it is in the form of GUI, Graphical User Interface. Okay, and the same thing can actually also be remotely managed by the same remote management PC. So when you have such scenario, there are multiple options in order to configure your device nowadays. First option that you have is with the help of GUI, and second has been very traditional, and we have been using that, and I'm pretty comfortable using that as well, which is CLI, command line interface. And by using both of these options, you can actually manage every device that's available there into the production environment nowadays. But a network device, for example, a router, has various functions that it has to perform. Think for a moment about some of the things that a router has to do in order to forward kind of a traffic or an IP packet, right? Whenever you have scenario like this, that you have a router here, then you have a router here, and you have a local area network over here, and you have a local area network over here, like this. And let's say this is 192.168.1.0. That's 192.168.2.0. And then that's 3.0. So in order for this particular device to transfer traffic from here to here, what's going to happen? The PC is going to figure out that the source IP, for example, is 1.2 and destination IP is 2.2. So after figuring out this information at the network layer, it's going to look at the local route table, right? The PC is going to look at the local routing table. If it doesn't find anything, it's going to forward that traffic to the gateway. And the gateway, of course, is the router. So when router receives that particular thing, it actually looks into the routing table. And the routing table has in like entries like 1.0 is connected to F0/0, and 2.0, let's say, is connected to SE2/0. So based on the source and destination, if it knows about both the network, it's going to forward the traffic onto the next thing. But in order to do that, like this is a high level idea about what the router actually does. But it has to check the destination IP into the routing table. Then there are routing protocols that are implemented like OSPF, EIGRP, BGP, right? These are the required protocols to learn about networks that are installed into the routing table. And then it has to also use the ARP resolution in order to get to know about the next hop on which the traffic actually will be forwarded, right? And then change the TTL value or decrease it by 1 whenever the traffic needs to be forwarded. And then it also needs to configure the or calculate the FCS calculation, frame check sequence, right? The Ethernet frame checksum has to be recalculated to ensure that the data integrity is not hampered, right? So all of these different tasks are basically done by a router. Same is done by other devices as well. There are switches that does the job of forwarding layer 2 traffic. There are firewall that actually does the job of either routing, or it also does the job of filtering the traffic as well, right? And then there are IDS, IPS, or load balancer who are actually, so almost every device needs to do the tasks that are assigned to them if they are doing the job that right. But all these different tasks that devices does are actually separated by different planes. And I'm pretty sure that all of you guys are experienced enough to understand that how these tasks are separated. Probably most of you guys are already aware about that all of these tasks are actually done by something you can say called as different planes, right? There are different planes that are divided. So the first plane that we have here is called as control plane. The second plane that you have here is called as data plane. And the third thing that you have here is called as management plane. These are the three planes that we actually have, right? That does the or that kind of divides the tasks that a device needs to do and on a daily basis, right? So we actually need to understand how each of these plane actually works and what difference does it make, and how traditional network creates issues whenever it can actually be assumed in a larger scenario possible. Okay, but yeah, till now, are we going good here? Any questions from your side? My flow of speaking, my writing, my handwriting, my annotation, are we good here? Any questions from your side or anything that you want me to improve till now? Please give your feedbacks, guys, so that we can like actually make changes in real time if it's needed. Thanks, Philip. Others, please give your inputs. Okay, I think we are good there. Perfect. So we'll move on in understanding how the control plane, data plane, and management plane operations are situated. But yeah, we'll just take 5 minutes off before that. I just need to use restroom, and then we'll kind of move on with the next topic that's there. Right? So yeah, just a 5 minutes refresher, and then we'll move on with the next thing. Cool. I'll see you in 5. Thank you. So when we talk about the same, that how the control plane, data plane, and management plane manages all the operations that you have. So let's take a closer look at the differences between the responsibilities of what these planes actually do. So when we talk about control plane, then you can say that control plane is responsible for exchanging the routing information. Okay, and it's there are other information as well, or there are other tasks as well that are dedicated to control plane. So first thing first, it does the routing information, or calculates the best routes and whatever it needs to actually do in order to form up the information of how the routing needs to be done. The second thing that it does is ARP resolution. It's also responsible for ARP table resolution as well. Okay, then it's also responsible for running or calculating span tree protocol at layer 2. You can say SDP is one of the thing in order to become or in order to create a loop free topology, right? Or learning the MAC addresses is something that is also done by the control plane and various other things. So it's like every information that a router knows about, that how to and where to forward the traffic, it's actually done by the control plane itself. Okay, and I'll be specifying more about it in a coming section. But yeah, then if we compare that with data plane, usually, data plane is not something that can actually be configured. However, control plane is something that creates output based on the configuration that we do. But data plane configuration or data plane information is propagated by control plane itself. So whatever data is that going to be there into the control plane, that same data is going to be taken by data plane uh, in order to like do all the forwarding transactions, which means like the data plane is responsible for usually forwarding the traffic. It relies on the information that the control plane supplies to it, right? And if you look at the things that data plane takes care of, it's about, you can say, encapsulating and decapsulating. So encap and decap the frames, right? Or you can say the packets as well, or adding and removing dot one q tags, 802.1q tags for VLAN and trunking things, right? Then MAC address learning and forwarding, matching IP destinations into the routing table, changing the source and destination address when network address translation is equipped in the device, and so on. All these type of tasks are basically done by data plane, or even you can say dropping packets for ACL. Okay, so whenever there is ACL configured, then dropping packets is also a task that's done by the data plane. So all the like data handling, that whether to forward the data or whether to not forward the data, and where to forward the data, and actually forwarding the data, all these tasks are actually done by the data plane. Okay, it deals with whatever traffic that comes up, but the control plane directly doesn't deal with that particular traffic there. Okay, and then if we talk about the management plane is not a real like big deal, I would say, because it's just about managing the thing. It's just about getting the access or giving the access to the user in order to be able to configure the device by either using CLI or by using GUI. So the management plane is just used for the access and management of your network device. For example, accessing the device through telnet or SSH or console port. Okay, but when discussing SDN, you can say the control and data plane are the most important to keep in mind. Okay, not really the management plane, but yeah. And here's how the tasks are actually done when you look at that. So you can see that, let's say that I'll create a box here. Yeah, and in that particular box, this is basically your control plane. This is kind of a best figure that I can have in order to explain how control plane and data plane works. So let's say that your this is basically a control plane of your router. Then you have OSPF running. Then you have EIGRP running, and you have static routing running. These three are the type of configuration that are basically running. And then, as you all might know, OSPF creates different tables, right? One of the table is neighbor table, and the other table that it creates is database table. And if we talk about EIGRP also creates neighbor table, and it creates topology table. Okay, and the database table of OSPF and topology table of EIGRP That's exactly where you are going to have like the all the routes or the routing like information that the neighbor is going to give. For example, if you have R1 here and you have R2 here and you have R3 here and you have R4 here, and then there is a destination, let's say called R5. So when if R2 knows about three routes to reach out to R5, knows about two routes and knows about five routes, then in OSPF, your neighbor is going to give you the best route. Sorry, in EIGRP, the neighbor is going to give you the best route that it knows about for the destination, right? And that's basically the three routes that you're gonna give, being R1, right? And then those three routes will be inserted into the topology table. But that's in case of OSPF. In OSPF, it's gonna give you all the three routes, all the two routes, and all the five routes. The neighbor give all the routes that it knows about, not the best one. And all these routes will actually be inserted into the database table that's gonna be there. So if you're running OSPF for the same set of networks, you're gonna have around 10 routes, considering the same scenario that we have. But and in EIGRP, you're gonna have three routes. So that's basically what all are the routes that will be inserted into these different tables that you have here. But that's not the information that a router uses in order to forward the traffic, right? The router actually uses the information that is placed into the routing table. And the routing table is just going to place the best route possible inside of it. Okay, to which we call as routing table. We also refer to it as RIB, right? Routing information base. And RIB also works in coordination with ARP table as well, where it knows about the like MAC addresses of all the next hops. And then the static routes, so database table is going to insert the best route, TT is going to insert the best route, and static directly is going to inject the routes into the routing table. It doesn't maintain any tables or so. And that's exactly how control plane actually works, right? And when we talk about data plane, then data plane just maintains something you can say like we call it as forwarding table, or referred to as FIB, forwarding information base. And if you have like interfaces that are connected, you can say that this is FA0/1, and then you have FA0/2, and you have some traffic that's coming in this direction. It will check into the forwarding table. Now, forwarding table is just kind of a replica of routing table, right? So you're gonna have the data that's coming from routing table and it's going to be inserted into the forwarding table, and it forwarding table will actually be considered every time that the device receives the information. It's going to look into the forwarding table and forward the data according to the information that's there. So if the FIB says that forward that traffic to FA0/2, it's going to forward the traffic based on that information itself. And that's exactly how like the control plane and data plane works in conjunction with each other. Make sense there? Any questions? Are we good in understanding how control plane and data plane actually works? Perfect. Now, what we need to actually see is how this behavior affects the traditional network that we have been working with. Okay, so there is like a lot of things that actually comes in play when you look at the traditional network. Now I'm going to like create or tell you a scenario where you will actually see that what all are the disadvantages of using traditional network in our scenario. So consider a scenario where you can say that like what all are the limitations of traditional networking. That's exactly what we actually want to see. So let's say that you have a scenario like this, that you have a data center environment and there is an ISP cloud. Okay, this is your ISP cloud, And then that ISP cloud is actually connected to multiple branches. So you have your branch 1 over here, and then you have your branch 2 over here, and both of that particular branch 1 and branch 2 has some routers or edge routers that are there. So I'll name those routers as B1, and I'll name those routers as B2. Makes sense? This is kind of Mumbai office, that's in India, and then let's say that's basically Dubai office. Cool, we have Mumbai and Dubai. And then your data center actually is situated somewhere over here in, let's say, London. Okay. Now, what's happening is there are some employees that are sitting in Mumbai and Dubai. So you can say that you have your local network. There can be multiple people, let's say around 500 users that are sitting over here. And then in Dubai office, you can say that with that particular switch, there are around 800 users that are sitting there. And they all have the access of reaching out to internet. Now what's happening is this is your DC, right? Data center headquarters. And you have some application that are basically hosted onto the data center on VMware ESXi server. Okay, so you have certain applications that are there. You have VM number 1, you have VM number 2, you have VM number 3, and you have VM number 4. Cool, these are the virtual machines that are actually hosting the applications, which means that there is a window, there is like a Dell server, and that Dell server has high-end resources like 48 cores of RAM and 48 cores of processor and around 1 TB of RAM, and all that particular server is basically something on which there are multiple applications that are hosted. Okay, now in order to make it reachable, you probably have a network infrastructure in a way that you have your uh, DC1 router and DC2 router as the redundant routers that are there, and you basically are connecting them like in this way possible. You get that? So both of the routers that are edge routers are connected to the internet, and then you have certain filtering mechanisms as well, like ASA1, and then you have ASA2, the firewalls that are connected with these routers in this way as well, and in this way as well, in a redundant way possible. You get that? And then you can say that these ASA firewalls are basically connected with layer 3 switches. So you have layer 3 switch 1 here, and then you have layer 3 switch 2 here. And then these layer 3 switches are basically connected to normal, you can say, access switches. So you have switch 1 here, and then you have switch 2 here. And we also have redundancy in every way possible, so that if traffic doesn't go from one way, the traffic actually goes from the other way possible as well. And let's say that the aggregation layer is connected like this as well. So you can say that this part of the scenario is actually, this part of the scenario is actually the core of the DC. This part you can say is the distribution layer of that particular network, and then these switches are directly connected. The switches are now directly connected to the server in a way possible. Make sense? So you can say that this is the access layer of that. Now, what's happening is all the application that the network actually has. I'll do some changes over here that in order to make it look a better way possible, I'll take it over here. Yeah, and then connect it over here like this. So what's happening is the people which are situated over here, these are basically the employees that are sitting in London office and that are sitting in Mumbai office and Dubai office. These guys are basically accessing the applications that are hosted over here. And the applications can be anything. It can be mail server, it can be web server, it can be FTP server, it can be an application like Salesforce applications or SAP application or any in-house third-party tool that the company uses in order to provide IT solutions to other companies, right? It might be ERP solution, it might be CRM solution, various other applications that actually gets used by the IT companies, right? So people or employees sitting in Mumbai and Dubai are good accessing these applications from this data center environment. Now, how would the scenario be implemented? Like if you think from a perspective of network engineer, then usually you would be having something called BGP over here, right? Then you probably would be like having, and this BGP will actually be done from here, right? This will be your BGP word. Then you can say over here you will already have, or you will have kind of VPN configuration over here, right? If you look at the layer 3 aggregation or distribution layer point of view, then you probably would be having OSPF or EIGRP, or you can say first of redundancy protocols like HSRP configured over here. And then you would be having certain like VLAN configuration over here, and entirely you would be having STP configuration over here as well. Do you all agree to this? Do you make sense that all kind of configurations will actually be done on different devices depending on what devices are there? Make sense what I'm talking about?
Yes.
Right, so whenever you have such kind of network over here, usually, do you all agree that in order to manage the data center environment, you probably would be having something like a scenario where you will also have a management PC connected to a switch, and that management PC will actually use putty in order to access the CLI, or ASDM in order to access the GUI of ASA devices, and it can actually reach out on every device possible. Over here, then over here, over here, over here, and over here. And that management PC then will access every CLI. And by using that CLI, it will be able to configure that device, or it will be configuring that particular device over there. Now, assume something like this, that after doing the configuration, there is an IT staff, or there is the senior management team actually decides to implement new application, or another like new application into the data center environment for the ease of the people who are sitting in Mumbai and Dubai. It's kind of an automated process. The company is moving towards automation, and all the operational tasks would actually be done by using that tool. And that actually tool will again be hosted onto the same ESXi server. So let's say that there is another couple of virtual machines that will be created, that will be VM number 5, VM number 6, let's say VM number 7 as well. And these three virtual machines now will be installed on the same ESXi server. Now, usually there would be different subnets, or there would be different IP addresses that will actually be used in order to access the virtual machines, right? That are there. And what's going to happen in that particular case is whenever you have certain, or you have such change into your environment, then you say that let's consider what are the things that you have to configure on your same network in order to make this particular change happen, in order to make the virtual machine available for the employee sitting in Mumbai and Dubai office. Okay, usually if you enlist, what's going to be done? First of all, VLAN configuration actually needs to be done, right? The VLANs have to be created. Then you also need to do STP configuration at layer 2 or at distribution layer. Then what will be the root bridge for the new VLANs that are going to be created? And then you also have to assign new subnets will actually be there, right? Then the fourth thing that you can actually see is HSRP modification actually needs to be done. Then the fifth thing that you probably need to do is OSPF fine tuning, advertising new networks like new subnet that you have created. Then you can say BGP advertisements for that particular new thing, or network address translation also needs to be done for the internal things. Then VPN configuration actually needs to be done there, right? And there are various other things actually which you need to do in order to make that particular change happen. Now, although there are network automation tools that actually helps us to often be able to configure all these devices, but usually in a traditional environment, just because every device has its control plane and has its data plane, or you can say CP is available everywhere, right? And every individual control plane needs to be configured separately because the control plane doesn't really talk with each other, right? So when you look at the thing, you can say that the configuration actually needs to be done one by one on every device that's there. And it's the major issue over here is it's very slow. It makes the process slow, and it is very manual process. And that's exactly what the biggest limitation of traditional network is. Like, while it only takes a few minutes to spin up a new virtual machine by an IT staff, it however might take a few hours for the network team to prepare the network and to make that particular virtual machine available for the other employees that are sitting on different sites there in Mumbai and Dubai, right? So for that, you need to create a maintenance window, and then in that particular maintenance window, you actually need to uh, like deploy this particular change there. So these virtual machines are now able to move automatically from one physical server to another physical server as well, right? You can just export the virtual machine and install it on some other network. Now, when they cross a layer 3 boundary, these virtual machines, you don't actually want to wait for the network team to make the required change, because every time that they're going to change the physical location, you need to make modifications to these. And every time you change that, this will kind of be a hectic job in order to change the configuration every time. And there is not just like 7 virtual machines. There are hundreds of virtual machines that gets hosted onto the production servers that are there. Usually the things can also be there into the cloud, but then clouds are also production environments, right? Physically, it's being stored somewhere. So there can be employees who are actually making changes to these things. Now, what trend nowadays is that everything should be virtual, right? It's not strange to see that this is also happening to networking as well, that everything is actually going virtual. If you see, like Cisco is basically a company who actually use proprietary hardware for a long time. If you want to use anything, you need to purchase physical routers and physical switches and everything. But now there are appliances like ASAV, right? You have iOS XE, which is like CSR 1000V. This is virtual iOS XE platform. You have iOS XRV. You have NX V. All these appliances are now available in a virtual environment possible, which means you can directly install them onto the ESXi, or the, you can say, physical server, and then you connect them with the virtual network interface card, and then those like appliances, be it routers, switches, in a virtual way possible, they will be able to communicate with the real traffic that's coming to your physical devices. Makes sense. It's just like licensing and all needs to be taken care of. But yeah, instead of having the physical devices, you can actually have virtual devices and make them communicate with whatever thing that you have in your production environment. Makes sense what I'm talking about? So this is basically a biggest limitation that you actually see when compared to traditional networking. Are we good here? Any questions in terms of understanding what is the limitation of traditional networking? So, how does SDN helps you in order to minimize the efforts that needs to be taken to come up with the limitations of traditional networking? how do you work with that? So when we talk about this thing, then SDN works in a way that you have something called uh, SDN controller. You have this thing that actually solves all the problem or most of the problem that you have there. So like SDN is kind of a thing or it's kind of a buzzword that's being very popular because it's not something that's coming up new now. It's been almost 10 to 15 years since SDN came out. And almost every organization or a vendor has a different opinion about what SDN is actually. And there are different products as well that they offer based on SDN technology. So traditional networking usually uses distributed model for control plane, like protocols like ARP, protocols like OSPF, protocols like EIGRP and BGP and others. They actually run separately on each network device. And these network devices basically communicate with each other, but there is no central device that has the overview of or that has like a central view over the control of all the devices. There's nothing like that. You have the access of all the devices to configure them via centrally, which means like by having a management PC that can actually reach out to the all the devices and then configure the devices one by one. That's still a limitation, right? So one exception over here when Cisco came out with is Cisco started giving controllers that actually would be able to manage all the infrastructure by using central point of touch. So that's when SDN was there, but it was not in a best way possible that it could have been there. Which means like with SDN we use something called centralized controller, to which we refer as SDN controller itself. Okay, and depending on vendor's SDN solution, this could mean that the SDN controller takes over to the control plane 100%, and that is the only it only has you can say, or you can say that you can have also an infrastructure where the devices also have the control plane, but it can also be managed from a centralized point of touch as well. So there are various different modules or models that are implemented of SDN. You have pure SDN, you have hybrid SDN, you have partial SDN, right? So there are different implementations of SDN, but yeah, usually the high level idea can be taken in a way that there is an SDN controller and that SDN controller manages all the devices. So you can have it in a way that, for example, this is your SDN controller. This SDN controller actually has like the ability to manage your control plane. The SDN controller has the control plane, and then you can say you have devices like these. So you have your switch 1, you have your switch 2, you have your ASA, and you have your layer 3 switch 1. Now in this scenario, what's going to happen is the devices are just going to keep the data plane. These devices will just keep the data plane and not the control plane. And what's going to happen is the control plane is going to provision the information into the data planes of these devices. So your SDN controller is actually going to control the data planes of all the devices that are lying in your underlying fabric. So the SDN controller can actually be anything. It will be connected, or you can say on the end, it will be connected to the management PC. This is probably going to be the management PC, and that management PC is going to have certain applications, and those applications actually can be Python. Those applications can actually be a third-party app. or something like Postman, or something like SD-WAN controllers, which we have as Vmanage, vBond, Vsmart, and Vedge. And all these, you can say, controllers of SD-WAN acts as the SDN controller that you have. And these controllers have the ability to manage the entire thing possible, or the entire infrastructure that you have in your WAN environment. Okay, so how do we actually refer to them? Okay, we refer to them in a way that the the things that you use in order to manage the devices from centralized point of touch, you call these devices, or you communicate with the entire thing over here, and you refer to them as northbound APIs. This is the northbound of the solution. And then you can say that, not right, let's say, this particular environment, this is going to be the southbound. So you use northbound APIs when you communicate with the SDN controller by using any tool possible. So the information is first given from management PC to the controller, which means inside of the management PC you will be using vManage. So you're communicating with the controller, which is actually managing the control plane. These things will be done by northbound, and then control like the northbound API will communicate with southbound API, because it's possible that you're using Python, you're using third party, you're using GUI, but all these instructions probably might not be understood, or might not be something that can be consumed by the devices. So the devices needs the information into the CLI way possible, or into an structured way possible. So how it works is northbound API takes the information from the user, converts it into southbound API understandable language, and then southbound API actually provisions that information to the data plane of the devices. Make sense what I'm talking about here? So this is how exactly you can say that the information is disbursed. Okay. So when you have to get a high level idea about what's northbound and what's southbound, the northbound interface is basically used to access the SDN controller itself. Okay, and this allows the network admin to access the SDN to configure the device or to retrieve information from the device. And this will be done through GUI and by using Python, or by using any specific program or tool that your organization has created. And the southbound APIs, or the southbound interface, is basically used in order for the network devices to communicate with the SDN controller. So the application to SDN controller is done with northbound, and the device to SDN controller is done by southbound. That's exactly how the thing is divided there. Makes sense what I'm talking about? Any questions over there? Romel is saying northbound is more on the management traffic, and southbound is, yeah, exactly. That's how you can assume it. Yep. Anyone else has any question? Are we good here? That's great. Now this is how the high level architecture actually looks like. Okay, and when we actually think about what a high level architecture would look like, when I say that northbound API is something that actually communicates with it, so what type of protocol are we using? Yeah, that's something that I'm going to talk about now. Okay, so when we think about the internal communication, that how does it actually works there? When we talk about that, then in order to understand that, let's say that you have something like this. When we think about the southbound API, sorry, the northbound API, as I told you, that we completely use. This is, let's say, your southbound. And the southbound has the control over the control plane of all the devices that you have there. So this southbound is going to communicate, or is going to use something called API. and that API can actually be configured, or that API can be consumed by either using Python or by using GUI, okay, or by using something like Java programming language, or by using something like Postman, which is one of the application that most of the people use, or it can be any specific controllers or solutions. And these controllers or solutions can be SD-WAN solutions to manage the WAN infrastructure, SD access solutions in order to manage the LAN network. You can have Meraki in order to manage the wireless solutions. You can have FMC, Firepower Management Center, in order to manage all the security appliances. And there are various solutions that Cisco have came up with in order to manage that. Now, how does the communication actually works over here? Oh yeah, it's northbound, not southbound. Sorry about that. Thanks, Devashish, for clearing that up. I wrote it mistakenly as southbound, but yeah, it's northbound. So when we think about the same, then how is this particular communication works? Now here's the thing. Everything that you see over here, the communication between the user PC or the admin PC and the controller, like the control plane, is done with the help of something called a REST API. Have anyone heard about it? Apart from Rick, because he has already gone through automation training. No? Okay. So REST API has basically been in a bigger trend now. Okay, almost every company is adopting, or every company is creating solutions based on REST API. And REST API is basically, you can say, a protocol that is basically used for configuring all the devices. So here's the thing: whenever you have now you see all the GUI thing is actually done with the help of a browser, right? Even if you manage your ASA, if you have this ASA with you, then you can actually connect with ASA by using management zero interface, and you can connect it with a management PC. And in this management PC, you can install ASDM, and in your browser, you can access that ASDM and send traffic to this device, that how the configuration actually needs to be done, correct? So how it works is you send an HTTP request to the device, and then you receive HTML reply. That is also in the form of HTTP, but yeah, we call it as the page that you see is HTML page. So here's the thing, that whenever you communicate with any controller, that controller is going to be there into, or that controller is going to be accessed by using a web browser. Okay, it's not going to be a controller that actually you download it. You basically access it by using your web browser, and in your web browser, whatever request that you send, it actually is conveyed by using HTTP. So REST API is nothing but HTTP itself, and there are different operations that are done in HTTP. Let's say that you have a router there, and then with that particular R1 you have a switch connected, and then you have a management PC. Now what you need to do is you need to fetch out the list of IP addresses that are configured, or list of interfaces that are configured with the IP address on R1. So what you are going to do, you are going to send an HTTP request, and that HTTP request will be in order to, like, that the HTTP request will store something that I want the list of all the interfaces that is available on R1, along with the configurational details that it has. And then your R1 is going to give you a reply, and that reply will contain list of all the interfaces in a structured way possible in JSON. JSON is one of the data structuring language that you have. And what you need to do is you need to enable REST API features onto this particular router. And when you enable REST API features, there are different operations that are basically done. So one of the operation that you do is get operation. The second operation that you do is post operation. The third operation that you do is put operation, and the fourth operation that you do is delete operation. There are other operations as well, but yeah, these are four of the most popular operations that we actually do. So what happens when you perform an HTTP request that performs a GET operation? The GET basically gives you the details, or GET operation is used to fetch out data from the device. The post operation, however, is used whenever you want to create a new resource onto your destination device. For example, creating a new loopback interface, or like creating a new access control list, or creating a new OSP of a process, or creating a new BGP neighbor, right? All these things can actually be done by using post. Put is basically used whenever you want to modify or alter any configuration onto the device. Okay, which means that you already have created a loopback, but now you want to change the IP address of that loopback. Or you already have an access control list created, but you want to add another statement to that access control list. So whenever you want to do modifications onto your configuration, you can use put operation. And delete, of course, is basically used to perform a delete operation possible. Do you understand what I'm trying to say here?
Abhijit, these all the get, put, post, and delete. It come under the HTTP request.
Yes, it comes under HTTP. So whenever you access anything, these are basically the methods that I use in normal browsing as well. The only thing that is different in HTTP and REST API is whenever you send an HTTP request in normal environment, you have a management PC and you probably are accessing some server, let's say google.com. Okay, so when you send a request, that particular request itself can be anything: get, post, put, patch, delete, depending on kind of the operations that you do. But the output that you get in your browser is in the form of HTML, right? It's an HTML page that you see.
Yes.
But when you look at the networking perspective that we use REST API, the operations are same there. The only difference is the reply that you get won't be an HTML page. The reply will be a structured data. It will be like in the form of a JSON. And yeah, as Debashish is saying, it's CRUD. So CRUD is something that Cisco is promoting, which stands for CRUD, and C stands for create, which is equivalent to post of HTML that we saw here. Okay, R stands for read, which is equivalent to get of HTML. U stands for update, which is equivalent to put of HTTP or REST API, and D of course stands for delete, which is equivalent to delete itself of the REST API features. So these are different operations by which you can perform all the probable like changes or configurations to the controllers. So what happens is you basically initiate one of the REST API operations, and those operations reach out to the northbound interface, and based on that the control plane basically is modified. And whenever the control plane is basically modified, then the control plane will actually forward that particular traffic from here to the necessary devices on which the configuration actually needs to be deployed, because you specify that on which device do you want this configuration to be deployed, whatever you're changing that by using REST API. Do you understand that?
REST API need to install on the controller side or in the management PC?
It's by default installed on that.
On the both side?
No, just on the northbound side.
Northbound. If we be specific, in the northbound in the controller or in the management PC? Where?
No, so REST API is not something that can be installed into the controller. The controller uses REST API as the transport.
Okay.
Yeah, like if I say that I want to send CLI commands on my devices, so what would I use as transport? The protocol stack would say that transport can be telnet or SSH or directly the CLI, right?
Yes, yes.
Just like that, instead of sending CLI commands onto the device, we are using GUI commands, or you can say JSON or XML payload, in order to send that particular configuration onto the device. And the transport protocol that we're using is HTTP. So REST
Okay.
API uses HTTP as the transport protocol. Make sense?
Yes, sir.
Perfect. Anyone else has any question? Philip, do you make sense of that? Aman, we have Lokesh as well. Please give your thoughts if you're good over here. Perfect. It seems that we are good over here in order to understand that how actually the communication works. However, you'll get more idea about how it actually works in practical environment, and then it'll make more sense to you that how it actually works. All right. So that was basically a major chunk of topic that we had to cover today in order to give you the brief about how SDN controller actually works. But yeah, the next section, however, I'll introduce you with how the labs are going to be done and how the topology would actually look like for the SDN that we're going to work with. Okay, and then we'll be good for the day. Let's take a refresher. Okay, a 10 minutes of break, and then I'll see you again. And then yeah, I'll explain you how the labs are going to be and how the topology will be made. Fine with you all? I'll see you in 10. Thank you. So if we talk about how the scenario is going to be in terms of implementing the solution, then we're going to work up in a topology like manner. I'll just explain to you that as well. So we're going to have a multi-site deployment, and then the site will be actually managed from a centralized point of touch. So you're going to have a DC environment like this. This will be probably your DC headquarters. And then you'll have kind of multiple transports. So we'll have one transport over the internet, and then we'll have another transport for MPLS. These are going to be the two transports that are available, which is basically this is a public transport, and that's going to be the private transport that we're going to use. And then you will have different sites there. You're going to have site 3, site 4, and site 5. Like this is going to be site 3. Let's say this is going to be site 4, and this will be site 5. And then that's gonna be site number anything, let's say 1. And then you will have the edge routers, or you can say you will have a router that will basically connect in a way that will be the edge router will be here, which will be Vedge, and then let's say you have a Cedge as well. Okay, customer. So the Vedge devices are going to be made by Viptela. That's also gonna be Viptela, and that's the router that's gonna be made by Cisco. Okay, so we're gonna have these branch routers, and then the underlying fabric can be in anything. There can be multiple devices, but we are not really concerned about that. We'll just like connect a single router over here with the edge device that you have, and then we'll have certain loopback interfaces like that in order to advertise the network. So we kind of ensure that the reachability from employees perspective in the data center environment is ensured there. Okay, and what you're gonna have over here is into the site 1 you're gonna have all the applications deployed. Let's say you have, and we kind of keep a redundancy over here, so you'll have VH1 and VH2. You'll have two VHs in your data center environment, and those VHs will actually be connected to both the transports in this way possible. Okay, and then the VHs over here will also be connected to both the transports. Oh, sorry. And then we'll keep one of like a site just connected onto the private transport, like MPLS only. And then you will have site number, let's say 2. In a way that this is exactly where your controllers are situated. So you're gonna have your Vmanage, you're gonna have your vBond, you're gonna have your Vsmart, and you're gonna have your CA certificate that actually generates all the certification for all the controllers. So certificate signing request and verifying that the devices are part of that particular organization will be done based on the certification. So we're going to have a router that will actually act as a CA router, like root CA certificate generator router. Okay, and then you're going to have then the management switch there, and with which all the controllers are going to be connected in this way possible. And then that switch is going to be connected to the internet and to MPLS private circuit. And this is exactly how that you're going to manage all the devices from here, over here, over here, over here, and over here. So by sitting over here, you're going to manage all your data center site, your site number 3, site number 4, and site number 5. That's how the management of the entire thing will be done. Now, internally, you're going to have a lot of other things also running there. Like you probably would have BGP there, you probably would have OSPF there, you have probably STP there. Okay, you have probably HSRP there, you have probably application aware routing there, you have ACL there, NAT there. There are going to be various other services that is going to be configured onto the inside infrastructure. But majorly, our first task after understanding the SD-WAN architecture and how the control plane and data plane actually operates, we're going to configure the onboarding process that we'll build up this topology. And by building up this topology, we are basically going to do the onboarding of all the Vedge devices that you have here. Makes sense? And then these devices can actually be managed by Vmanage, one of your controller, which can also manage the Vsmart and vBond, and then all the Vedges there. So Vmanage is going to be the controller on which you will be doing day-to-day tasks. Vmanage has the control over everything that you see there. So there is specific requirements that we have. Then you have clustering options. We have various other things that's going to be implemented. So this is kind of a high-level idea about how the topology is going to look like. We're going to have multi-site deployment and multiple transports, and then you're going to have a site dedicated to kind of you can say manage all the infrastructure that you have. Okay, geographically the locations can be different or they can be in the same country, and everything can actually be tested on a virtual environment possible. The labs, however, are going to be done in a simulated environment, which is going to be ENSDWI. So ENSDWI is a simulation that we're going to use in order to implement everything that we're going to do, or every lab that we're going to do in SD-WAN. That's how the lab idea is. Are we good here? Any questions?
Abhijit, I have a question. This is all in this topology. We have all SD-WAN related devices as a topology only. So what I need a setup where SD-WAN devices will interact with the non-SD-WAN device.
No, you're talking about the edge devices?
Yes. Let's say I have a site number 6, which is a non-SD-WAN running site where all my site 1 to site 5 should interact with non-SD-WAN related site also.
Well, the communication will of course be possible, but you won't be able to do the configuration of those devices. So there are a specific set of devices that actually needs to be used in order to like connect those devices with SD-WAN fabric.
My scenario was like, let's say if we have a site number 6 where in that site number 6 we have only a Cisco router and followed by the LAN.
Okay, no, let's say that, let me get a clear idea about that. So you're saying that this is a site number 6.
Yes.
Right? And in that site number 6, let's say this router is anything, let's say 7200 series router.
Yes.
And then you have a LAN connected with that. That's what you're saying.
Yes, and this router 7200 router is connected to internet and MPLS.
Like this way possible.
Yes.
No, this device cannot be managed by the SD-WAN fabric.
I know that it cannot be managed by SD-WAN fabric, but I need the reachability of all the site 1 to site 5 to site 6. The communication should happen between the sites.
Yeah, that can be ensured.
Okay, that was my concern. That's it.
Yeah, that can be ensured. That's not. I said you that communication is possible, but the management of those, like the configuration of that device via SD-WAN or via these controllers, will not be possible in that case.
Yeah,
Perfect.
got it.
Sure. So that's how the scenario is going to be, and I would say that was all that we had to look at, like that we had to look on our day 1 of this particular class. But yeah, the next thing or the next section that we're going to discuss is introduction to SD-WAN, which is kind of a big topic. But yeah, I'll keep day 1 as short and simple, where we kind of got to know about the SDN, we got to know about the content, we got introduced with ourselves. And yeah, then once we are good over here, then I'll take it further to the next class, or in the next class, about getting to know about SD-WAN components and the SD-WAN architecture. These are going to be tomorrow's topics that we're going to cover, and then slowly we will kind of move on. We'll keep it short and simple, okay, without stretching, because if I start now with the SD-WAN topics and all, or with the SD-WAN architecture, we won't end up with that particular concept, and then we'll again have to revise it. So we'll keep it till this only. I hope we are good. Okay. Sometimes we probably might need to extend the class. Sometimes we probably might need to shorten the class depending on the topic. We'll kind of arrange the time zones. Hope everyone's good with that. So that was our class number 1, that in which we discussed almost everything about SDN and what are the challenges that we face in traditional networking scenario and how SD-WAN comes up and helps you. However, there is a lot that we actually need to see. This was kind of a trailer that we saw today. But yeah, I hope you enjoyed the class and the communication, the teaching method, and the flow and languages, everything. I expect everything is good there. If you need anything to be improvised or changed, please feel free to give us the feedback so that we can work on it in real time instead of like just having a feedback noted down for our next trainings. So yeah.
Hi, hi Abhijit. It's Devashish.
Yeah,
Abhijit, what about
Devashish.
the books and lab books or something you are providing now?
Yeah, 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 yeah. I am going to provide you the lab books. Don't worry.
Okay, okay. Thank you. Thank you.
Everything will be provided to you. Don't worry about that. Cool, perfect. So thank you so much everyone for tuning into this session. You'll get the recording soon as it gets uploaded. Okay. And I'll see you guys tomorrow at the same time. Till then, take care of yourself. Thank you so much for joining in. Bye bye. Thank you.